This video is for the effects of a dilation on the perimeter and on the area. So perimeter, including circumference, is a linear measurement or distance. And so remember, it's the distance around a shape, how far it would take you to walk around the entire shape. So when an image is dilated, its perimeter is just multiplied by the scale factor. Now, when an image is dilated, its area is multiplied by the scale factor squared. And so remember, area is the amount of space something takes up, or if you had a wall, how much paint it would take to paint that wall. Okay, so what we need to do, if they don't give us the perimeter, we need to find the perimeter. Same with area. So in example 1, it says a square with a perimeter of 16 is dilated with a scale factor of 4. What's the perimeter of the image? So remember, the perimeter, you just multiply by the scale factor. So 16 times 4 gives us 64. So that would be the perimeter of the new image. So in example 2, it says a triangle with side lengths 5, 7, and 10 is dilated. So this time we have to find the perimeter. So for a triangle, we just add up all the sides. So 5 plus 7 plus 10 would give us a perimeter of 22. And then again, we just multiply the perimeter times the scale factor. And our new perimeter would be 11. And so this would be like P prime. That's our new perimeter. All right, example 3, a triangle, a right triangle, DEF, has these vertices. So let's graph this. 1, 2, and then 7, 2, and then 1, 6. So this is a big time multi-step problem here. So first I got to find the perimeter. So these two sides are pretty easy. These two sides, let's see, 1, 2, 3. This one has a side length of 4. This one has 1, 2, 3, 4, 5, a side length of 6. But if you remember, we can find this length using Pythagorean theorem. And so we're going to use the reduced version here, a squared plus b squared, because I have two legs. Here's your right angle. So remember, two legs, you would add them up. So 4 squared plus 6 squared. And I'm going to get a really wonky number here. Hang on one second. You're going to end up getting like 7.2. We're going to round it off there. So that would be the distance of that side. So find your perimeter. So 4 plus 6 plus 7.2. So you've got a perimeter of 17.2. So you just multiply the perimeter times the scale factor. And so your new perimeter would be 51.6, or about. And then finally, a rectangle is dilated. The perimeter of the original rectangle was 34. The perimeter of the dilation is 17. What scale factor was used? So we know that perimeter times scale factor gives us new perimeter. So what we can do is we can plug in what we know. So we know the original perimeter was 34. We don't know what the scale factor is, but we know the new perimeter is 17. And so now you've got an equation that you can type in to y equals. So I have 34 times x and then 17. And then second trace 5. And it shows me right here what my scale factor is, whatever my x is. So your scale factor here would be 0.5. This one also works if you use what we did, finding scale factor, new over old. You could have just divided 34 by 17. All right, so now area. So a rectangle with an area of 18 is dilated by a scale factor of 3. So in these, I take the area and I'm going to multiply it by the scale factor squared. So 18 times 3 squared gives me 162. So that's the biggest thing here, is to remember to square your scale factor. So here I've got a triangle with an area of 75 as dilated with a scale factor of 1/5. So I would take 1/5 and I would square it. So 75 times 1/5, and then I've got to square that. And I would get 3. All right. And then here we've got a graph again. So I've got 0, 0, 0, 3, 3, 0, and 3, 3. So here I've got this rectangle. Actually, it's a square. And so knowing it's a square helps because all I have to do is find one side length, and then I know the rest of them. So to find the area of a square, length times width, and then we multiply the area. So this is the area. Area times the scale factor squared. And I would get a new area of 81. All right, and the final one, a triangle is dilated. Sorry, guys. Triangle is dilated. The area of the original triangle was 7. The area of the dilation is 63. What was the scale factor used? So we know area times scale factor squared equals the new area. So if the original area was 7, we're looking for the square scale factor, and then the area of the dilation is 63. So again, this is one that I can stick into y equals. So 7 times x squared equals 63. And then second trace 5. And so this time I get a scale factor of 3. So that's it for this video.